Welcome to Community Office Hours. This is the Consul edition. We do this every second Tuesday of the month. Today, we have a special guest with us from the Consul education team, Daniele. And we are going to talk a little bit about HCP Consul. We've had a number of other live streams about HCP Consul, but I don't think we've had someone on Office Hours speaking about HCP Consul before. So pretty exciting. Now, as always, we'd love for your questions in chat. Please be professional, welcoming, and inclusive as you do participate. If you have questions or any specific comments that you'd like to provide, we have some folks from the HCP team in the chat. So if you have HCP Consul specific questions, do drop them in. I will read them out, and we'll have some folks perhaps answering their questions. With that, let's get started. Daniele, would you like to introduce yourself?
Yes, hi everybody, I'm Daniele Carcasole and I work in the Consul education team. Today we will talk about end-to-end workflow using Terraform and Consul, using as a base a set of tutorials we wrote past quarter, so that we will guide you through the tutorials and you will get like some hands-on on what is possible to do with HCP Consul and how to automate the client workflow.
Awesome. Okay, so I guess we should talk a little bit about HCP in general. HCP stands for HashiCorp Cloud Platform. It's a set of fully managed HashiCorp offerings. So in this case, we're talking about Consul, but there is Packer. There's also Vault right now as well. You could check those out. There are other tutorials related to HCP Vault and HCP Packer. But today we're talking about HCP Consul. So if you are interested in using Consul for service mesh or for service discovery, and you don't want to manage the Consul servers, the HCP Consul is a good opportunity for you to sort of create the service mesh and the Consul servers that you need, and then you can add on to it. So this is what Daniele is going to show today, which is what happens when you create these servers. What can you do? What can you connect to it? What do you get sort of out of the box? Some caveats to HCP Consul, and in general, when you use HCP, you're going to hear us talking about connecting clients or connecting some kind of service to the servers. When you use HCP Consul, you need to create something called a HashiCorp Virtual Network. In this case, we're running on AWS, Amazon Web Services. So in this case, you do need to create either a peering connection or transit gateway between your VPC and the Consul server VPC that's coming from HCP itself. So you'll hear a couple of different things. Daniele, I don't know if you're planning to talk a little bit about when you're going to create the HashiCorp Virtual Network or go into it, but at least I wanted to define it before we get into it.
Yes.
Cool. I think we're ready to get started. So what are we looking at first?
Yes. So this one is the starting page of the HCP Consul Automation Collection. And this tutorial provides you an introduction on the functionality and all the possible scenarios we already have pre-made for you that you can use at a starting point. As Rosemary mentioned, the HCP, so HashiCorp Cloud Platform, in the Consul incarnation is a fully managed service mesh as a service, meaning that with few clicks or with a bit of Terraform code, you can have a fully deployed and HashiCorp managed service mesh in which you can then deploy your applications without having to worry about the caveats or the minutiae of configuring Consul on your own servers. Well, the tutorial also shows you a video, so you can get this introduction repeated still with my voice by following this video. But to continue what Rosemary introduced, there are like a few core concepts and a few steps that you want to go through in order to deploy load and applications on HCP Consul. So first of it all, let's see like the overview. The final result that you want to achieve is the one showed in the picture. So you want to have a cluster, an HashiCorp, an HCP Consul cluster that is paired with your AWS VPC, and inside your AWS VPC, then you want to have your clients. Peering, what does it mean? Means that all the networking operation that HCP performs are performed using an overlay, a networking overlay called HVN, as per HashiCorp Virtual Network. Creating an HVN is usually the first step that you do, and then you refer all the networking to that HVN. So what are the detailed steps for this? So, well, first step, you can create an HCP Consul cluster and an HVN, and you can do that directly from the HCP UI, or as we will see during this office hours, this demo, you can have a Terraform code that will automate that for you. The second step is that you create an AWS VPC. This example, and at the moment, HCP Consul is available only for AWS. So all these operations will use some AWS jargon on it. And in this case, we're going to deploy all our resources in a VPC that we need to create. After that, as mentioned, we will make the AWS VPC and our Consul cluster able to communicate by peering the connection. And then the last two steps, step 4 and step 5, we are going to deploy Consul on the different client nodes. And finally, we're going to be able to deploy the actual application that constitute our nodes. While doing and documenting this workflow, we realized that all these steps, despite being like easily performed even through the UI of AWS or HCP, are sometimes they need some coordination, and it's always better to not leave those performed through UI, because they might be error prone, you might forget things. And in pure HashiCorp style, we decided that the best way to automate this is through Terraform. So to help you get on board faster and to test the functionality in a quicker way, we deploy the way we call it, end-to-end scenarios that will help you get a pre-built deployed environment containing the HCP Consul cluster, containing the HVN network, and even performing the peering and the client deployment for you, so that you can directly get it the moment you want to get on board with HCP Consul. These scenarios exist in many versions with many different client workload architectures. And to start it, we can start directly from the HCP Consul UI. So let's move a bit on the UI. As you can see from the overview, of course, 1 second that it reloads, but from the overview, we directly, well, you can see the different products available. In this demo, we will focus on Consul, and you can notice a small link that says you deploy with Terraform. We will go through these procedures in a minute, but this one permits you to directly download Terraform code that works out of the box, and that then you can edit to apply to if you have like different or specific configuration to make. Going on with the tutorials, the scenarios we propose as pre-built, pre-made use cases are one using EKS, so that you can test if you want to test and use HCP Consul as the control plane and the service mesh for your workload on Kubernetes. Or if you, we have another one for EC2 in case your workload is based on more VM style, let me say old-fashioned workload style, or if you are in the process to migrating, or you have like old or legacy applications or even new applications that need to reside on a specific VM. Last but not least, from the out of the box, we have an example scenario that uses ECS host your workload and your applications. The second last tutorial in the collection will also show you how to customize one of the files that we're going to download to just adapt to deploy and use Consul on an existing AKS cluster that you might have already deployed. So this might be interesting to as a second step, the moment you see how the out-of-the-box experience work, to go and test the code reusing some workload that you already have. Okay, so let's...
Yeah. So before we start on the next piece, just to clarify for everybody who's looking at this, if you want to deploy, let's say, your own apps with Consul Service Mesh on EKS, ECS, or EC2, you can take the modules and the Terraform configuration and adapt it to what you need for your application. This is a good way for you to learn and to get started with the configuration. If you're not as familiar with Consul, this will sort of give you something out of the box that you can sort of pull apart and figure out what changes you need to make. While if you're not as familiar with deploying the applications on EKS, EC2, or ECS, this is a good way for you to understand the Consul pieces, but use something out of the box with an existing application that we're providing as a demo, so that you can explore it. So use it to reverse engineer. By no means should you be running the demo like this by it is in some ways by itself. You adapt it to your production environment as you see fit. Bring your own, use it as a way to sort of reverse engineer and bring your own networking configurations, as well as potentially EKS or ECS or EC2 configurations as well.
Yes, thanks, Rosemary. And yes, what you say, what Rosemary was saying is that the modules and the demo we will see will deploy a pre-built demo application that we consider like complex enough to accommodate most of the use cases, but of course that's not going to be your real use case. So from there on, you have like plenty of examples to then extend and adapt.
So there was a question in chat, Daniele, and someone asked, what about Nomad?
Oh, well, one of the use cases, so you saw the tab, but one of the use cases with using EC2 as the platform for the application workload is deployed using Nomad. So the demo scenario will deploy an EC2 node, and then you will deploy Nomad on the node, and then use Nomad to then deploy Consul and the applications in Docker containers in this case. So that this also is a valid use case to see if you want to also introduce Nomad in your deployment process. Well, this gives you an head start. Otherwise, you can make the deployment adapt to whatever tool you're using. In our case, again, going with the HashiCorp model, we thought that Nomad would have been like a nice use case to show. Okay.
Yep.
Any other question?
No, that's the one question.
Perfect. Then we will move to the process. So once more, if you want to try this at home after the office hours ends, you only need two tools. Well, one tool and one login access. So you need Terraform, Terraform 1+, and you need an admin access for the HCP Cloud portal. You might go on with something less than an admin access. We will see that in a minute. But you need admin access in case you didn't get credentials created yet. So to get started, the first step from the overview, you can just click on Deploy with Terraform. And this is going to bring you to a new page where you can decide which environment you're going to create. And you can see there are like a bunch of selectors. The first one we want to focus on is use existing VPC versus create new VPC. These two options permit you to either reuse a VPC where you already have some workload on or already some resources on, and this might be very useful in case you want to adapt your existing workload to just integrate with the HCP Consul. The one we are gonna see and edit today is the one that also creates a new VPC, because in the philosophy of this demo, you are basically testing this functionality on an empty situation. So you will also want to create the VPC. Then, as you can see in both options, you have the option to pick the runtime between EKS, EC2, or ECS. Since the demo that is already on the tab is on EC2, we are going to select this and proceed and see what are the next steps. Next, once you pick the runtime, you can decide the HCP region where you want to deploy your HCP Consul cluster and your HVN, and the VPC region where your workload is going to be deployed. So in this case, since I'm in Europe, I'm just going to select US 1 and US West 1 in both, and I'm going to show you where this reflects in the code generated. Next, it's time to think about authentication. In order to execute this code with Terraform, you will need a service principal key that has at least contributor role. How can you create this? Well, you can create this if you have admin access. You can do this step right now from the UI. If not, you will need an admin to create a service principal key for you and provide you with the credentials. But then, so let's assume that you can access you are an admin and you can access the access control tab. From there, give it a second to load. You have users. As you can see, this is my user, and you have service principals, and I have like a few of them that I use during my different tests. Once you have one, you can create a service principal here. That is test demo HCP. You can define the role. As mentioned, you only need contributors, so you don't want to create unnecessary credentials for your user when not needed. You can save the service principal, and then from that page, you can then create a service principal key. Once you have this, you can copy the client ID and the client secret, because you're going to then use them to set up the environment for your machine. Going back to the deploy with Terraform page, you can then use the service principal ID and the secret and export them in the CLI in your bash using these two experts and placing your actual values at the end. Next, the UI provides you a Terraform configuration that you can just copy and paste on your local machine, and then that you can execute with Terraform to make the deployment. As you can see, the choices we made earlier with the region we picked are now reflected in the VPC region and in the HVN region. We selected AU West, so now the same is reflected in the Terraform code. And we have some automatically generated cluster ID and HVN ID. These ones are self-generated for your simplicity, but you can edit those names if you want. The system will not complain. Just make sure that you use a univoc cluster ID and HVN ID, otherwise you will get an error. But then you can follow your own naming convention. This one is there so that you can remember that The naming in this way is just to remember that this one was automatically generated. After that, you can copy the code, open your favorite editor that I don't have here. 1 second. There we go. And then just, well, you can create, I have a bunch of folders here, but you can create a new folder and call it end-to-end demo. You can then create a new file that we can name main.tf and then paste the generated code in it. Well, this is basically all the configuration part you need. From this on, we can simply just go and check if Terraform likes what we did. So we can open a shell. We can open a new terminal. Let's go to the folder we just created, demo. Okay. After that, I saved the credentials on a file, but you need to set up the credentials. And the credentials, you need to set up them not just for HCP, but even for AWS. So I have them prepared in here, but you can export them using, well, whatever tool you prefer. You can even use Consul to just set them up, but just export the credentials. So from this moment on, we can communicate and interact with both AWS and HCP, and then we can start seeing well, the standard Terraform then. So we will start with Terraform init. And this one will just download all the providers or the modules needed for the code to execute. And you can then plan to see what's going on in case you deploy this. You will see the resources that will be created. As you can see, this scenario creates 33 resources, and then you can just Terraform apply, and this one will make the deployment go live for you. We will start this near live, and then yes, and the deployment will start. The deployment takes between 10 and 15 minutes, at least on my machine, and being it a bit tedious to just look at Terraform output for the whole time, we will just, I just made a couple of deployments beforehand so that we can just jump on them and see what goes on. So let me just open a new tab. Let's go back.
As you open a new tab, one thing to note if you're using this Terraform configuration, it is creating the VPC and I think the HVN as well, right, Daniele?
Yes, yes.
Yeah. The peering with AWS peering, they need to be different CIDR blocks. So if you're adapting this to bring your own network, do verify that they do not have overlapping IP address ranges. With peering, you want to have 2 separate IP address ranges. That is very difficult to validate within Terraform input variables. So you will not necessarily find them like validated in a number of modules, for example, because long story short, but basically input validation only works for the locally scoped variable in Terraform and not necessarily on another variable. So just double check that your IP address range for your VPC does not overlap with that of the HashiCorp virtual network.
Thanks. That was very nice detail. That it's easy to forget and then get like random errors.
Yeah, it will complain at you. It won't complain until after you've done it, and it will say that you can't peer. So
yes.
Yeah, do double check.
Good. So like moving on the so as we see the deployment keeps going and it creates the HCP Consul, the HVN route, as you can see is peering. But let's move to the already deployed scenario that we have in a different folder to see that it was already deployed. We can use the Terraform output for seeing what was already deployed. And as we can see, in this case, we deployed the EC2. So we have Nomad, and the output provides us the Nomad URL. We have the application URL, and we have a way using the URL to access the Consul UI. The Consul root token, Consul gets automatically bootstrapped, the ACL gets initialized, and a root token gets created, and the token is provided to you as output, but is marked as sensitive. You will see that's also in the tutorials. Sorry, I didn't prepare for this command, but we provide you a way to retrieve the output from Terraform. So being sensitive, you have to specify the actual variable you want to see in Terraform. Otherwise, you will get this sensitive command, and then we can, if you want to visualize it, you can just use the Terraform output specifying consul_root_token. And this one, we're going to use this token to authenticate with the Consul UI. So going back to the browser, let's first go to the Consul UI. This is the UI. As you can see, we are not logged in. ACLs are in place, so we want to click on login and use the token that we just retrieved from Terraform. And as you can see, now that we logged in, all the clients are now shown as services. And you can see we have, Nomad, server and client. And then we have we have Consul that appears as a service instance. And then we have all the services that constitute our application, namely the front end, payment API, and product public API, DB, and the internal product API. We can see the fact that this one is deployed by, from the Terraform output. Another URL that is provided is this HashiCorp's URL. HashiCorp's, we didn't mention it yet, is the actual name of the application. And once it gets deployed, you also retrieve a URL to access the UI. So we're going to open it live just to prove that we didn't register that earlier. And this one is a nice web application that helps you buy HashiCorp branded coffee products. So you can select, as you can see, you can select the product and then click on buy. All the operations and the communication across the services are now passing through Consul Service Mesh. So basically, without having to define anything except the AWS region and a name for your HCP Consul cluster, you now have a fully working Consul Service Mesh with a ready workload deployed. So the step will be, the next step from here will be to edit the code that now deployed the application to just substitute it with your actual workload, your applications, and basically you are already good to go, or at least you don't have to think about all the caveats in introducing Consul from scratch in your organization, in your workflow.
Yeah, I think Daniele, can you go back to the Consul UI?
Yes.
It's also important to note that when you create an HCP Consul cluster, it has all of the secure configuration enabled by default. So if you could go to, let's say, like token access control tokens. So ACLs are enabled, which means that it will issue, you will need tokens with the correct policies attached to the clients, as well as the services that are getting registered. And if Danielle, you could go to intentions as well. If you're using Service Mesh, if you're using Service Mesh, it's a default deny on the intentions with HCP Consul because it has ACLs turned on. So effectively, if you are struggling to secure your console cluster, and you want sort of a nice secure by default, easy way to test something in console, or you want to explore what a default configuration would be like, HCP Consul has it pretty much out of the box, so you don't have to worry about it yourself.
Yeah, and well, I'm sure you are familiar with the concept, but then this is also gives you an idea on how to test the intentions live, so that we can actually try to break things, even though we shouldn't do that for the
I need
cause of.
I need to order my coffee, Danielle. I'm breaking.
I know that the demo gods are not always happy when you try this, but let's say now we denied the possibility from front end to go to product public IPA. Let's try to refresh the page and see what happens. There we go. We successfully broke it. Let's see if it's as easy to fix it in this case. So by going back to intentions, we are now basically reallowing the communication between the front end and the product public IPA. And ideally, well, we're back on track. Rosemary, you can have your coffee.
Thank you. I appreciate it. We had one request in chat. Daniele, are you able to dive a little bit into the Nomad configuration itself? Like if there are job files associated with the way HashiCorp's deployed, how is Nomad working with Consul?
Yes, so the Nomad configuration is not production-like, is one single node. But yes, it uses job definitions to deploy the applications in Docker. You can actually check the Nomad configuration just playing a bit with the module source code, and we can see this. Let me see if I can find it. So in the last tutorial of the collection, the Terraform resources for HCP Consul automation, there are like a bunch of links and a bit of explanation on what are the different components that have been used to make the automation possible. And in there, we should have something related to Nomad. Let me check. No, wait. Yes, the HCP EC2 client. What we can actually well, it's so I don't have any easy way to find that code without searching in the registry. We can do that like at the end if you want. Oh, well, somebody actually did it.
Yeah, I popped it into the chat. Yeah, if you can click on the sub modules, at least you can. Yeah. So
let me just open it. Move it.
That's it is in the Terraform registry under the HCP Consul module, and it's a sub module under there. So if you click on the source code, you can go ahead and someone can, if you're interested in the Nomad configuration specifically, it's in here. Oh yeah, there's a HashiCorp.nomad file too. What do you know?
Wait, let's see if we can find that. Maybe sorry.
Yeah, if you go to the HCP and then templates.
Yes.
They have the HashiCorp's Nomad
file.
file.
There we go. Mm-hmm. So this one is the job definition that deploys the different modules of the application, the different services, and you can see that in this case they are Docker containers, and you can see the way they get defined, which port they use, and so on. So this one is all automated. So all the work behind the scenes in this case is made by Nomad. Different cases in one of the other use cases, the one for Kubernetes, for example, where the deployment is made with Helm chart, I guess, or with the definition files.
Is there anything special about how Consul, like HCP Consul, connects to the HCP the console client on the Nomad host connects to HCP Consul?
There is nothing special. So in the pure functional way, the same configuration will work with any other console data center as long as you have like with similar configurations. In this case, it's just that all the security and everything is already took care of on the HCP side, and the client actually uses the auto-config procedure that we have documented for the on-prem version in the Learn guides. In this case, all the magic behind it, all the magic that is like long and tedious process is already took care of. So the client just need to be able to recognize the HCP Consul nodes as trustworthy, and everything else gets automatically generated on the fly, starting from the gossip encryption to TLS certificates for the service mesh service nodes.
Got it. Cool. Thank you. Since we're leaving this one, we may have to increase the font on this if we return to it, but I think we're okay. We're okay for now. Thanks.
And then, so let's see how the process goes. As you can see, this is still creating and we are talking over it, so it might not like it, but we can move towards the next demo we had. That should be, no, it's this one. No, as you can see, it's destroyed. Sorry, this one. And we can use the same standard. So we finished the deploy on this. This one is the second example we're using, the AKS workload. And as you can see, the output is slightly different. In this case, we still get console URL, the root token that is still sensitive. So let me close a bunch of tabs so that we can start fresh. And let's open, again, similar process. We can access the console UI. And we need to bump up the font. We can log in. We need to retrieve the token. This one. We can copy it. Log in here. And as you can see, the services are slightly different. So our application workload is still there. The services are already, the name is the same. The difference is that there is nothing Nomad related in this case. But everything else is still in place. You can still see that there are tokens automatically generated. One nice thing to see is that the services are identified using service identity tokens that are a nice model to use in case you have like many services you want to deploy. You don't want to, they don't need any specific permission except the possibility to register themselves and be part of the service mesh. So by just creating service identity with the name of the service, Consul will take care of the necessary permissions for them to be registered in the catalog and spin up and register the Envoy sidecar proxy. And we also have the same sets of intention. This one is a bit more messy, as I'm sure that not all of these intentions are needed. I guess we just wanted to play safe in the scenario. But then that's also something you can try and experiment. You saw before the way how to break up things. You can go and deny one by one the things and see if the application still works. Well, when it breaks, you know that you didn't have to touch that intention. But in general, you can see that there are like different ways to automatically deploy the intention. The previous one were made by Nomad. This one is managed by Kubernetes CRDs. One nice thing with the automatic, the end-to-end scenario for Kubernetes is that it also provides you with a Kubernetes configuration that you can use even locally to connect with your Kubernetes cluster. Actually, the tutorial uses it provides you a nice shortcut to actually, as soon as I can find it, there we go, to export kubeconfig using Terraform output, so that you don't have to manually type things. We can try this and note that kubectl, of course. Oh, I'm sorry, this one. Okay, sorry, we just found live a typo in the tutorial. It's not // but it's just Terraform. Well, any place that is inside your path. So if you have it installed, just Terraform works. And sorry.
There we are.
There we go. So now we are connected to the Kubernetes cluster. The Kubernetes cluster is connected to Consul HCP. And from this moment on, even just reusing this same cluster, you can start playing around and deploying your own parts of the application and see if that the way it integrates with Consul. The same way you can deploy extra services in the EC2 instance and see how that plays along with Consul, how they show up in the UI. You can play with the intentions and see permissions. And then the moment you're ready, the moment you got enough familiarity, well, it's time to remove the HashiCorp application, as much as we like it and everybody loves coffee, and then substitute it with your actual use case.
Yeah. If you follow this workflow, it does deploy by Helm chart. You will have to set Helm values so that you remove you disable the creation of console servers in the Helm chart. So if you're doing this with just the Helm values file, you'll notice that the console server enabled will be false, just because you don't want to create the console servers. You want to pass an existing console server in there. The other thing that's really nifty is that the Terraform provider, I believe, does output like the correct Helm values file for you to use as well. I think that was what it was with the provider. So if you're doing this and you need, let's say, like the template for the values, you need the template for the console server or the general cluster config. You can export it by the Terraform data source. I think it's a data source. It generates it for you, so you can easily go and take it and use it for other Terraform configuration. And that's kind of how the Terraform modules themselves are chaining all of these parameters together.
And well, last thing, apparently we were, well, not lucky enough, but we had enough time. We spoke enough time.
We did. Oh, good.
Yeah, to get the last demo, the one that we did live, to complete. So, well, we now have a third Consul cluster, HCP Consul cluster, and we can actually review all these things directly from the HCP UI. So if we go back to overview, just to conclude the thing and see what we actually deployed, you can see that Consul shows that we have active clusters, and starting from, well, the virtual network, well, now we have 3 virtual networks. The 2 of them are of the demos that I just showed you, that we pre-deployed before this video. But the third one is the one we just completed. You can recognize them if we go back to the code. That one had this identifier, and as you can see, it's this one. And the same is going to happen one-to-one in this case on the Consul tab, because now we have 3 Consul data centers up and running. We can see the versions, and we can see the HVM that they refer to. Again, this one, the UI helps you with the having a visual representation on what's deployed, but since we deployed everything using Terraform, the right way to undeploy it in case you want is to still use Terraform. So that's the last thing we can do live. We can just destroy the demo we just launched. Sorry. And this one will make a bit of the calculation, what's needed. As you saw, we deployed 33 resources to spin it up, and Terraform is actually figured that it needs to destroy 33 resources to stop it. You can just confirm it using yes, and the old demo is going to be teared down, and you will see that at the end of this process, nor the HVN nor the Consul data center will be present anymore in the HCP UI, as well as you will not have any more resources deployed on AWS. So this is a very nice way to test something and then clean it properly when you finish testing.
Cool.
Yes, and I guess that was about it for me. Any remaining question?
I think that was the last of the questions. We didn't go through ECS today. ECS is available, so if you would like to use an ECS cluster with HCP Consul, there's one over here. We just didn't deploy it today.
Yeah, but you will see that the process is identical. You will follow the same steps, download the Terraform code, and then you can use the Terraform dance init, plan, and apply to have the demo up and running.
I might have to borrow it. It's the Terraform dance. All right. Well, folks, if you have any other questions, you can always reach out to us, post on the forum, or join us for another office hours. Big thank you to Daniele, who went through pretty much almost every single scenario and bravely created and deployed one of them live. If there are any other scenarios you're interested in seeing with HCP Consul, let us know as well. And in terms of next events, there is a live stream happening with Learning Live with AWS. You can tune into that on Thursday. And then there's going to be a stream about Consul on Friday. So if you are interested in getting to know Consul a little bit more, learn about it, we're going to be talking about Mesh Federation. With that, if there are no more questions, I'm going to close this office hours for today. Hopefully, we will see you on the next one. And big thank you to the Consul education team and Daniele for putting all of this together. And a huge thank you for the HCP Consul team for sort of adding these Terraform modules. It makes it a lot easier to deploy a lot of configurations between the Consul clients as well as the sample application.